Now it is interesting also to look from a meta level that the roots or so to say, the anchors of these hexachords form a structure which has 2/4 and 1 whole tone. Keep this in mind. I will come back later to this. I call it the hypertetractys and I will tell you later why. So, but these hexachords are not keys. They are not tone repertoires. So the lowest note is not always C, or C is in the traditional structure never the lowest note. So we have the modes. Here we have one mode which is more modern. It's the Ionian mode. It has been, in theory, been introduced by Clarianos in the 1540, around 1540. How does now mathematically speaking, how does the hexachord relate to the Ionian mode? We have the folding patterns and the step interval patterns here of the hexachord. Here's the ascending pattern of the Ionian mode. Think of major, no? It's the major. Tone, tone, semitone, tone, 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 semitone. Then there's traditionally a divider here in the middle. And you see that the hexachord, on the one hand, the hexachord is a prefix to that. I mean, you know that. But also, it is interesting to see that the two periods are now being concatenated. So the primary period is the fifth, and the secondary period is the fourth. So the building bricks of the essential information of this otherwise redundant structure is being brought, is concatenated here. And the same thing works in perfect duality for the foldings. So the folding of the hexachord is a prefix to the folding of the Ionian mode. Here I do something which is not common traditionally in the music theory, but I will argue in favor of this extra F sharp. And we see again the two periods are concatenated. You see also a duality between the periods 4 and 3 on that side. You have letter frequencies 2 and 5, yeah? 2 semitones and 5 whole tones. In this picture you have periods 2 and 5, and you have frequencies, letter frequencies 3 and 4. Yeah? There are 3 fifths and 4 4. So that's a nice exemplification of the duality of the two trees, and I will show you that works out for all the central words and all the standard words. So, in other words, the standard words are the mathematical generalization of what we find as the Ionian model. Okay. Aldo De Luca should be credited for the following insights. Let's start again with the central tree, with the double periodic structure and so on. And we look at these central words. So each of these nodes has two periods, as we have seen here. Yeah, you see these are prefixes which then can be repeated. That looks a bit exotic, but it's nevertheless the right way to do. I mean, AA is a prefix of this period, and if you look at the whole picture, that's the right way, within the same here. So the construction I just showed you for the Ionian mode works nicely. You append the two prefixes to each other, and you get a binary tree. This is known as the standard tree. So these are the standard words. You have a negative standard word and a positive standard word, and they have this divider in it. So this is known mathematical terminology independently of the existence of these musical modes. And you can do it on the other side. Now I show you those periods as suffixes, and you get another tree which is known as the anti-standard tree. And there you have positive and negative anti-standard words. Okay, so we have both of these trees. And there's some, so far we have seen that the standard words are the periods of the hex of the central words. So there's another way of looking as central words being inside, being prefixes to standard words. I'll show you this. Oh, you can reconstruct the standard, the central tree from the standard tree by simply truncating the last two letters. So the one lives in the other and vice versa. I think as an answer to the initial question, how does the hexachord serve solmization in a world of modes? We can see that in the light of this double periodicity, the hexachord is the longest undecided structure. Once you add one more letter, you make a decision and one periodicity is lost. So to say these hexachords are useful to keep some ambiguity and you have a shorter structure. And as soon as you have one more letter, you get into this world of standard words. So let me give you some musical anti-same words here on the anti-standard tree. Yeah, I summarized this. So the standard words are the fundamental prefixes of central words and represent their periods, and the central words are the prefixes of the standard words of length -2. And the same thing equally for the anti-standard words. So some history on the well-formed scales. So these are structures on the circle. In the modes we are sensitive towards the register of the octave, and I will show you the variety which comes out of this in a minute. So there are two papers, influential papers by Norman Carey and David Clampett from '89 and from '96, and also related work which was not known over the Atlantic by Evald Wash, the famous number theorist on scales. Yeah, this is a nice example to exemplify what well-formedness is about. Here you see that every bar, the chord goes one tone down, okay? And so you can then see that in the half bars, so here the bass, the bass of the harmony actually is C, you can divide every step in 2/5, even though the diminished one. You can use the diminished fifth here. The bass would be A here, and A half diminished chord. So you can say every step can be divided in 2/5. And this is actually what Handel does here in this Kasakaya. On the other hand, then he diminutes the fifth by steps. So you can say every fifth can be divided in 4 steps. So this is a kind of circular definition of the diatonic scale. And you see the solution is modulo 7. Yeah? There you have the solution. 4 times 2 is 1 modulo 7. And the well-formedness says that counting steps in terms of scale generators or counting generators in terms of steps is a multiplication. It's not just a wild permutation, it is really a multiplication operation. Let's listen to this example.